Now let's learn how to do derivatives of natural logs. Remember, integration and derivatives are inverse functions. So when we did the integral of 1 over x dx is the natural log of x, it's quite natural that the derivative with respect to x of log of x is 1 over x. And we, of course, have to have x equal positive. Now, what do we do if we don't have x but a function of x as our argument of log? Well, then it's just 1 over u times the derivative of u with respect to x. And we're going to write it this way, u prime over u, where, of course, again, u must be positive. U must be positive. Oh, sorry. Okay, so let's try a couple. d dx of log of 2x, natural log of 2x, u is going to equal 2x. So u prime is 2, and yes, you have to write this down. So derivative with respect to x of the natural log of u is u prime over u. So this is 2 divided by 2x. It's 1 over x. That's interesting. We're going to see why this is the same thing as derivative of x in a minute. Now, let's look at this one right here. U is x squared plus 1. So u prime is 2x. So the derivative with respect to x of natural log of u is u prime over u. So this is 2x divided by x squared plus 1. Now I need to see all of these steps on homework, tests, and quizzes. Now let's look at this one. Let's let u equal x cubed, then u prime is 3x squared. So the derivative with respect to x of natural log of u is u prime over u. So this is 3x squared divided by x cubed. Or, two of those cancel, I'm left with 3 over x. That's interesting. Now what about this one? We're going to have to use a product rule here. All right. This is, let's let f of x equal x. Then f prime at x is 1. G of x is natural log of x. G prime at x is 1 over x. So we're going to do the derivative with respect to x of fg, which is f prime g plus g prime f. So this is 1 times the natural log of x. I'll go and put it there. Plus g prime, 1 over x times x. So this is natural log of x plus 1. And I don't like writing it this way, so I'll make it 1 plus the natural log of x. Now, let's look at this right here. This is kind of complicated. Let's, I can say u is this whole mess and do the derivative, but that's kind of ugly. What if we cheat a little bit and expand this? Now, hint, we could have done this before. Let me write f of x as the natural log of x plus 3 times the natural log of x squared plus 1 minus 1/2 times the natural log of 2x cubed minus 1. Now I can take the derivative with respect to x, and that's 1 over x plus 3 divided by x squared plus 1 times 2x minus 1/2. Let's see, 2x cubed minus 1 times the derivative of this, which is, okay, so that's 6x squared. Let me rewrite this. 1 over x plus 6x divided by x squared plus 1 minus, let's see, that's going to be 3x squared divided by 2x cubed minus 1. And you can stop there. You don't have to find least common denominators or anything. The calculus was done right here. Now, there's also something called logarithmic differentiation. And suppose I wanted to take the derivative of this, and that's supposed to be a semicolon there. So x is not equal to 2. So we don't have any zeros here. What if I want to take the derivative of this, but I don't want to have just this horrible nightmare doing it? What if I take the natural log of both sides? Right there. Okay? So I have the natural log of y is the natural log, twice the natural log of x minus 2 minus 1/2 the natural log of x squared plus 1. Now let me take the derivative. So this is going to be y prime divided by y, and don't worry about that y there, it's okay, we're going to deal with it in a minute, is equal to 2 over x minus 2 minus, let's see, 1 over 2 x squared plus 1 times 2x. Now I know this is a little bit ugly. What if we go on and get our common denominator here? You don't have to. You can leave it like this. But if we do all of this factoring, we're going to wind up with x squared plus 2x plus 2 divided by, I'm going to wind up with x minus 2 times x squared plus 1. Now I just skipped a little bit of algebra here because I'm going to run out of room if I don't. Now I'm going to solve y prime is y times x squared plus 2x plus 2 divided by x minus 2 times x squared plus 1. At this stage of the game, just go on and plug what y is. It's a mess. And please don't simplify anymore from here unless it's like really straightforward. Okay, so there's y. And let's see what we've got here. Times x squared plus 2x plus 2 divided by x minus 2 times x squared plus 1. All right. Now I can do a little bit of simplifying here. That's a little bit easier. Let me change pen colors. One of those will go away. These can be combined. All right, so can't factor the numerator. So this is x minus 2 times x squared plus 2x plus 2 divided by, now these are the same basis, so this is x squared plus 1 to the 3/2. All right. Now, your turn. Give it a go. Restart the video. When you're done, we still have a bit to do. Now, what happens when you want to take the derivative and it involves an absolute value? It turns out this is just u prime over u. Now, let's look at the two cases. Case 1 is when u is positive, then the absolute value of u is equal to u, and so the derivative with respect to x of log of u is u prime over u. Okay, that was kind of trivial. What happens when u is negative? All right, then the absolute value of u is equal to minus u. So the derivative with respect to x of the natural log of minus u is what? Well, when I do this derivative, u prime is going to equal minus u. Okay, so this is natural log of minus u is 1 over minus u times the derivative with respect to x of u, so that's minus u prime. I forgot my prime there. So this is u prime over u. So as long as you stay away from u equals 0, you're in good shape. Now, let's do a couple where we're taking the derivative of we have an absolute value sign stuck in there. In this case, we're going to let u equal cosine of x. U prime is minus sine of x. So f prime at x is u prime over u. So it's minus sine of x over cosine of x. And we can simplify that to be minus tangent of x. Oh, can't read that. Minus tan x. Okay, give it a go. One more short thing to do. Turn the video back on when you're done. My hair was not very good there. Okay. Now, what if we want to find relative extrema? Well, we know relative extrema occurs when the derivative is 0. So let me take the derivative of this. Y prime is x squared plus 2x plus 3, and derivative of the numerator is 2x plus 2. So I know y prime is going to equal 0 when x is, well, when 2x plus 2 equals 0 when x equals negative 1. So I know I have a relative max or relative min. Let's look at y prime when x is, say, negative 2. So this is 2 times negative 2 plus 2 divided by negative 2 squared plus 2 times negative 2 plus 3. So that's negative 4 plus 2, so that's negative 2. 4 minus 4 over 3. So this is negative. Next, let's look at y prime of 0. That's 2 over 3. That's positive. So we know we have a relative minimum at x equals negative 1. When x is negative 1, what is y? Y is the natural log of negative 1 squared plus 2 times negative 1 plus 3. So this is natural log of 2. So we have a relative min at the point negative 1, 2. Okay. See if you can give it a go. Take the derivative of this with respect to x. Okay. And then find the relative extrema. When you're done, finish your homework. Have a great evening.